Okay, welcome students, week 9. And all of the instructions for the week I put onto your news so that you can see it, as you can see here. We have a lecture, which I'm going to start in a minute. There's also 2 labs. The labs are Python labs. They're quite simple. If you pay attention in the lecture, I'm sure you'll have no trouble with the labs. There's also an assignment. In the assignment, you have some added tasks to do in code.org. So I did notice this when it came to the mid-semester grades. There are some people that didn't get a full mark in the assignments. That's a shame, because that should be available to you. It's just a matter of doing all the stuff in code.org. But I will be remarking that, and those 10 marks do not fully sort of appreciate until the end of the semester. What I will do at the end of the semester, I'll have a look at what you've done in code.org. If you've done it all, you get the marks. Okay. So that's being pretty liberal, I think. Just make sure that you do it. So far, you've got to do 1, 2, 3, 10, 12, 15, 16, 22, 25, and 26, all in code.org. If all of that is done, you get the marks. Good luck. I mean, you can't really do it wrong, right? Because, you know, it tells you how to do it, right? So, I mean, if you've done it, you've done it right. Sorry, you asked me something. Yeah, it's got to be when I put the grades in, then I'll have a look at what's been done. So get it done, you get the marks. And as I said, that's 10%. It's kind of 10 easy points. I was a bit sad to see at mid-semester, a lot of people didn't have their 10 marks, which, you know, they should have, because they should do that. So today we're going to start a new lecture on Python. Hooray. So we're talking about Python. It's for you to start looking at, once we've had a progression, right? We went through talking about how we analyze problems, you know, computational thinking. We went through the decomposition, the abstractions, the algorithm and the pattern recognition. Then we got, well, pattern recognition, lastly, algorithm. And the algorithm, we looked at how we could do that with a flowchart and how we could do that with pseudocode. Once you got your flowchart and your pseudocode, next thing is you should put it into a computer code. And so that's what we're going to talk about today, is about how things would look in a particular pseudocode, a particular computer code, which is Python. There are lots of other computer codes that you will use, and you will use in your degree. So you'll be learning Python, which is a very nice computer language. It's not a baby computer language. It's nice to start out with, because it allows you not to have to use those curly braces, not to have to use assignment of type to our new variables and constants. It's nice to use, but it is a full programming language that is used for people developing applications for the internet, and is used for people working with networking. So it's a proper computer language. You could happily have a career writing Python programs. No problem there. You will, however, in this course, you'll learn other computer languages. You'll learn JavaScript, which will help you in your building of your websites, because JavaScript will give you what we call dynamic websites, where you can put code onto a page, which you know, people push a button on a page and launch some computer program, which may then be a Python program. So you'll be learning JavaScript, and what other programming languages? PHP and SQL, so that you can work with databases with your web programming. So you'll be learning a few programming languages. Let's start with Python. Okay, so what about the basic syntax? With Python, as it says, we work with one line at a time in Python. Because it is a interpreter rather than a compiler, it's easy for us to sort of follow that one line at a time. And you'll see in a minute, because I will open up Python for us, you'll see that we can, well, maybe you could do that now, I guess. You can get Python working for you quite easily by just going, if you haven't got it on your computer, you should navigate to python.org. And when you get to python.org, you'll find that there is a drop-down menu for downloads. Now you'll choose the download depending on your operating system. So, I mean, most of us have got Windows, but some people have Mac, and you may also have some other operating system. You might be running Linux or Unix or something else. Probably you're using Windows or Mac. Or anyway, so if you're running Windows, you'll download that download for Windows. If you're not running Windows, supposing you're running Mac, which I'm not, then you've got a couple of other releases that you can use for that. So choose it quickly, carefully, download it and install it. I'm not going to download and install here because I've already got it downloaded and installed. But so once you have it installed, you'll find that it'll install under, it won't be installed under the name Python. It'll be installed under the name of IDLE. IDLE is what we call an IDE, which is an integrated development environment. So what IDLE does is it gives you an interpreter for Python program, gives you an editor. It gives you these two screens. So what we've got here, do you see the three chevrons? Chevron looks like a greater than symbol there, right? Three chevrons together. That means that you've got the line by line interpreter, and how you interact with this is you put in a line of code and immediately it interprets that and processes it. So for example, if I just go and do a Python command, usually this is the first thing that we do. Now, if I was going to try and do that in, say, C programming language, or in, that'd take 15, 20 lines of code to say hello world. If I was going to do that in Java, again, another 15, 20, because I'd have to set up a class, all kinds of things like that. If I was going to do it in COBOL programming language, which is third generation programming language, that would take like about 52 lines of code. I'd have to set up many different areas of code to get that going. What do I have to do in Python? Say print hello world, boom. So I think it's intuitive, easier to work with. Now that's working with the shell. If you want to work with a program, then you're going to do this thing here and create a new file. So that's going to be different. Notice there's a little difference between the shell and this. I don't have the chevrons. And here's where I write a file, which will then be processed one line at a time, but it'll be processed one line at a time, but from start to finish of the file. That's where I do most of my, I'm not going to say most, it's where I do all of my Python programming. I never do one line at a time like this. I always write a program, save it and run it. And you can do that in the file here where you choose a new file. It's not the shell. And you sort of do that. So you're going to create a program, save it and run it. We will do that a bit later on in today's lesson, because we got some little programs to run because they show up in the lesson. So why not? All right. As it says, we do one line at a time. If we use this character here, the hash character, everything to the right of the hash character on a line will be treated as a comment and will be ignored by the Python interpreter. All right. So we use that to enter our comments. And when we do that in the Python editor, you'll see that it'll show up as red. So look for that in a minute. I'm going to be doing a Python program with you, and you'll see that. Now, indentation, as it says there, it's very, very important. You get the wrong indentation in your program, and it will not work. All right, so we're very careful on the indentation. Now, what Python does to help us with our indentation is it uses for every control structure starts with a colon, where we say the name of the control structure. Maybe it's an if then. Well, we don't use then. We just say if some condition. We're going to use a control. We're going to use a colon. If we create a new function, we're going to use a colon. Then all we have to do is after the colon, press our carriage return, which is the return key or enter key, and it will take us to the right indentation. Then after every line, press enter. Then if we want to go back to our original, we're going to backspace and work from there. We also use a tab. Don't use spaces. Okay, so when we're typing, don't ever use spaces to get your indentation. You'll always get it wrong, right? So we just use the colon and an enter. That'll get us to the right place. As I said, indentations is everything. Now you might say, well, that's a pain. Sure, if we're using Java or we're using C+ or something like that, doesn't care about the indentation. We can indent it or not indent it, and it'll work. And the reason why it works in those programs is because they use the curly braces, just the same as we did in our pseudocode. We're not using curly braces. So Python gave us a bit of a break. We don't have to start and end curly braces in the right place, but we have to use block coding, and how we do it is with a colon and indenting. So about variables, Python makes variables a bit easier too, because we don't have to explicitly say what type they are. I think that's on the next slide. I don't see it here, but yeah. Okay, so how we create a variable is we just state a name. We use the equal sign, which doesn't mean equal in this case. What it means is takes the value of, and we put a value of it, and then Python will automatically, implicitly assign the type to the variable depending on the type of data that you're using. So if you create a variable and you set it equal to, or you give a value to it, which is an integer, then that variable will be an integer variable. If you set a value to it, which is a decimal value, then that variable will be a float. If you give it a string, then it'll be a string, etc. Now, the other thing that I should mention there is here in the green. It's important. Those three ways of saying law. Now, law, we could set law as a variable name. So imagine that law is a variable name. We got three different ways of doing law. Each of those would be a different variable in Python. So Python looks at the case. The case is important. So when we're typing, be careful of how we do the case. What we generally do is we use lower camel case. That is that we start off all of our variable names with lowercase. When we have more than one word in the variable name, the second word, we capitalize the first letter. And that keeps it easier for us. Remember, in the pseudocode, we can use the same kind of rules as we did in the pseudocode. With our constants in the pseudocode, we made it all uppercase like this. So if we looked at this, we would think that, oh, well, this one here is a constant. This thing here, well, we don't know what to do with that because that's not the way that we do variables. So typically, our variable would be, this one would be a variable, the second one would be a constant, and then the third one is something that we typically wouldn't do. So here is how we could create variables in Python. Very easy. What we're doing here is we create a variable by the name of num. We initialize it to a value of 2. Python will look at that and say, oh, that's a number. So this num is going to be an integer because that's an integer number. Python will just automatically make that an integer. Likewise, we create a variable called DEC for decimal, I suppose, and we give it a value of 2.1. Python will see that that's a decimal number, and we'll give that a type of float. Here we give another variable called sentence, and we give it a string. Now, how it's a string is because we're using these quotes. Now, when you use the quotes, doesn't matter if you use a double quote or the single quote, just as long as you close it with the same kind of quote as you opened it. So this could have been single quotes, but you can't use a double quote and a single quote together, right? If you open with a double quote, you close with a double quote. If you open with a single quote, you close with a single quote. But otherwise, Python will look at that and say, oh, that's a string, and it will store it as that. Now, when we talk about variable types, we can talk about simple variables. We can talk about complex variables. So a string is kind of a complex variable because it's actually made up of a bunch of smaller parts. The smaller parts that make up a string would be the characters. And that's cool because we'll look at that in a later slide, is we can actually index and identify each of the characters that make up a string. And that's kind of a cool thing. All right, so if we have numbers that are going to be assigned to variables, those variables will be either an integer variable or a float variable, depending on how they are created, or depending, we can do another thing called casting. It's not on this slide, but it's on another. But that, if they're a number, means we can do mathematics on them. So the signs here, they should be familiar to you. Not the comma, that doesn't do anything, but The plus sign, we use that to add two values together to then store it in a variable. The minus sign is just for subtraction. And the star is used for multiplication. We must use the star. We don't use an X or anything like that. We don't just put a number outside a bracket like you would in mathematics, and then that's a multiplied. That's not how it works. You actually have to physically use the star in there. Now we have this special kind of division, which, well, we got three. And we got another one. We got modular division, which is not spoken about in this lab. So just keep that in your mind. One day, Mark is going to talk about mod divisions, not today. Modular division is the opposite of this division, which is called integer division. Integer division, what it does is it removes the remainder. So the remainder is lost. So if you take a number like 10 and you say integer divide by 3, the value that you'd get from that would be 3, because 10 divided by 3 is equal to 3.333 repeating, right? So what integer division does is removes the decimal portion of that value. And so that all you've got is the integer part of that value. So that's why we call it integer division. And how we show it is just with 2 slashes like that. 1 slash, that's our normal division. And normal division will almost always give you a float value. So if you do normal division, you should put it into a variable, which is a float variable. If that variable is being created in that statement, that'll happen automatically. But if you've created that variable somewhere else as an integer variable or something like that, you may create an error if you try and then store a float in it. So just be aware of that. If you try and store a value into a variable that's already been created and you try to store the wrong kind of value, you may get an error. So then you might have to change the type of that variable, but it is possible to change the type. So yeah, we use type float whenever we're going to do something that's going to give a result, which is going to be a decimal. I think I've just mentioned that. All right, so here we use the word convert. I don't know if you guys are going to be reading anything about this, but if you are reading something in a Python book or anything like that, you'll see that they use the word casting. So this is a form of casting. What may have happened is we've got a variable called myvar. Maybe it was created and it was an integer, just because we put an integer number into it. Then if you do this thing here, you state float and put brackets around the variable. What that will do is it will, as it says, convert that variable to type float. If it was type integer before, after this, it would be type float. We do that. I've already shown you that when I've done the inputs. When we do an input, the user, we ask them to enter a number, then we have to convert whatever they enter to a float or an integer. And the reason for that is anything that the user enters from the keyboard, when you do an input, is going to be a string. So we have to convert that string to a number type, either to a float or an integer. Okay, so I mentioned that a string is a special kind of complex variable. It's a complex variable because it contains smaller variable, which are characters, right? So it's a bunch of characters together. Now, when we create a string variable like this is creating a variable called greeting, and it's storing the value there of this string. We know it's a string because it's between quotes and there's more than one character. So that actually is addressable. We'll talk about that in a minute. But here what we're doing is we're creating two variables, greeting and subject. They can be manipulated through a process that we call concatenation. Now, big word, strange word. For sure, it's going to show up in a quiz. All right, that's just the way our quizzes work, right? So it'll be concatenation. What is it? And you have to notice that two strings can be added together to make a bigger string. Now, what would happen if you did this? Maybe we had a third string and we called it greet. Greet takes a value of greeting plus subject. What it would do is it would say, hello, everyone. So you can add two strings together just by using a plus between the variables, or even just with the strings. you can do that. And I think there's a print statement that shows up in one of these slides, which does that exactly. This slide is a little bit more about the strings. Strings, as I said, they're a complex variable. They're actually made up of a bunch of characters put together. So we can use functions that work with the complex variable. So we've got this one function, or you could call it a method, whatever, len, which is part of the Python sort of code. When you load Python up, len is built into the language. So we can just call len and run it anytime we want. What len will do is whatever string is put between the it's not braces, the brackets there, len will return a number, which is how many characters in that string. So that's, oh, sorry, go back. So that's why len of this is going to return the value of 5, because there's 5 characters in that string, right? 5 characters. So we can use len if we want to do something to manipulate strings. And there's a lot of fun we can have manipulating strings, and maybe we can do that later. But once we know the number, if you know the number, you could use the number, how long the string is, to run a counted loop. So we know about counted loops, right? So we know how many characters there are. So we could use a loop to do something to every character. We could do that. There's a lot of other things we could do, and we can look at that later. So how do we access each individual character that makes up a string? As I told you, a string is a complex variable made up of a bunch of characters. Each character can be located in the string by its index. How the index works is starting from the first character in the string, going to the last character of the string. They're numbered in ascending order, starting with 0. So 0 is the first character up to, in this case, so this string has got 5 characters, start counting from 0 up to 4. So that means we can access them and do all kinds of things with them. Well, how we can access them is if we state the name of the variable. So greeting was set to hello. And what we can do is we can access, what's this doing? Using square braces, we could access a particular one of these characters. So if we just had the 1, if we just put in between the square braces greeting 1, that would get an E. But doing a greeting and then a :4, what that does is it says starting with character 1, which is not the first one, right? Because the first one is 0. Starting with character 1 and not going to 4, stopping before 4. That's what it means. Start at 1 and stop before 4, and all of those characters. So all of those characters would be the characters starting at 1. So, and stopping before 4 would be the characters in positions 1, 2, and 3, which are E, L, and L. And so this gives us this idea of a substring. So this is a string because it's made up of more than one character. And it's a substring because it was taken from this other string. And so there's all kinds of manipulations we can do with that. We can do things with the front and the back and all the rest of it. There's a lot of fun that you can have with that when you do a Python course. Might do that. I don't know how much of that we're going to do in this course. We'll see though. Some other things that you can do with strings. We've got some inbuilt functions into Python. And I mentioned one of them in the previous slide, which was len. Len will give you how many characters in the string. Got some others. We've got upper, which works on a string, and it will convert that string to all uppercase letters. So here we got greeting.upper, and it's going to give you whatever is in upper will be all converted to uppercase. Oh, sorry, whatever's in greeting would be converted to all uppercase. Likewise, greeting.lower, everything would be converted to lowercase. So those are good, especially if you're sort of processing somebody entering some values for a, say for a password or something. Maybe you wanted everything to be in lowercase. You can just convert whatever they type, whether it's upper or lowercase, convert it to lowercase and then work with it. That's quite a common thing. Now, remember a couple of slides ago or at the start of this lesson, I mentioned to you that with our control structures in Python, we start the structure with a colon, and then the indenting will just come from that. See this? Here we're having an if statement. We've got the colon, and then these two statements are indented from the colon. Then what's happened is what they wrote is the next statement there is unindented. It's indented to the same level as the if. So what that means is if this condition is true, these two instructions will be run. If it's not true, they won't be. Now, the last instruction on that page will always be run because it's not part of the if. When you finish the if, you go down and you do this instruction. It's always going to happen because it's not controlled by this condition. But these two instructions here will only happen if the condition is true. If the condition is false, they will be skipped over. Does that make sense? That's how an if works. There's more ifs. This is one type of if, the simplest if, where, if true, do this. And if it's not true, we just skip to the next thing. Then we're going to have an if else, and then we're going to have an if else. Anyways, let's have a look at that. I think we've got an actual example of it. Yes, we do. Now, what I think we should do here is we should take this example and actually turn it into Python code. Well, we can do that. This is so easy to do. If you come across some code like that, I'm just going to copy that, and I'm going to create a new file. And this is about age or something. Sorry, I have to put my glasses on because I can't really see the keyboard. So age, what? I don't know, 18 or something like that. It's or more, something like that. Now, notice that when I started typing, I started with a hash, and then all the code became red, but only on that line. Now I'm going to copy in the stuff that I got, or paste in the stuff that I got from that slide. Now, I can tell if this is working by the colors. Okay, so I've got different colors for special reserved words in Python. So notice that the input and the int are colored. That they are reserved words in Python. They mean something. So the input means that this is going to go on the screen as a prompt, and then whatever the user enters at that point is going to be returned into this variable. The int means that whatever comes out from the user is going to be converted to an integer. That's good because it's age. The green stuff means it's something that's going to show up on the screen. Okay, so green stuff is what we do when we do a print or when we do an input. So then we've got an if with a condition. See the if with the condition? So if this condition is true, which would be if the age that was entered by the user is bigger than 18, then we're going to do these things that are controlled by that colon, which means they're indented after the if. So there's two things that happens there. First, we create a variable called double, and we assign a value to it, which is 2 times the age. Then we print out, and look, remember I talked about a minute ago, concatenation, where we add strings together. That's what we're doing here. So this green stuff is a string, right? That string is added to another string, but this string has got a number in it. So that number is first converted to a string, and then it's added to this string. Then we got another string. Then we got another number, which we convert to a string. So we have 3 strings there, or 4 strings. They're all added together to make a string. Let's see if that program will run. In order to run the module, we'll have to save it because it's a file. And so ask you now, the thing is, how this program works is if the age is more than 18, it's going to do this. If I put an age which is less than 18, what do you think will happen? You guys, come on. What would happen if I put 17? 17 is not bigger than 18. Or I could put 18 because 18 is also not bigger than 18. Believe it or not, 18 is not bigger than 18. 18 is 18, but it's not bigger than 18. So what should happen? It will just say, have a nice day. Now, why does it say, have a nice day? Why doesn't it do this other stuff? Because it's not true, right? The only way that these two things are going to happen is if this condition were true. Let's run it again, and this time let it be true. So run the module. How old are you? So this time I'm going to say 19. And it says in 19 years, you'll be 38. So 38 is 2 times 19. So what it did is it took the 19, multiplied it by 2, assigned that to the value of double, and then double was printed out along with 19. There you go. That's a nice little program. So we see how the if works. If it's true, we do these things. If it's not, we don't. We always do this line. It always says, have a nice day, right? Because that's outside the if. It's not controlled by the if statement. All right, so that was kind of fun. I hope you enjoyed that as much as I did. Let's have a look at this. Next one. Now we're going to make it just a little bit more complex. Same program, we're just going to add something to it. What if we put an else? Now the else, in this case, this perfectly represents what we did in pseudocode. If, then, else. If, then, else. How if, then, else works is, we have only one condition here. If this condition is true, we do this stuff. That's straight after the colon. If it's not true, we do this stuff after the next colon. Notice that the else has got another colon. So if it's true, we do this. And if it's false, we do this. One of these two things is going to happen, right? And then we always do this stuff that's outside. So how does that look in our program? If the age is bigger than 18, we're going to double the age and blah, blah. Otherwise, we're going to get the remaining age. Now, I noticed when I did this that there's a little bit of an error in this. This often happens, right? We're going to do some debugging. Not a problem. Debugging is totally possible. So again, I'm just going to take that code. We'll put it into our Python because I can't be bothered typing it. I mean, you know me, I'm not big on typing. We've got our program. It's not going to run because I'll tell you what, there's two problems with this. I don't know, is the lesson that boring? Oh, I see. So I noticed that there was some problem with this. So I don't know, sometimes because it was in a file, and I think this is because it was on PowerPoint. Anyways, that age value was a bit messed up. The other thing is we don't want to print their age. We want to print the remaining. If we do age, it's going to give a problem. So, I mean, we had two different little bugs in there. I think I got the bugs out. So let's try and run it. Nope, still didn't like age. All right, let's try that again. 18 minus age. Maybe I'm going to take out this space also. Remaining takes a value of 18 minus age. I don't know, there's a space in there or something that was not working. So it seems to work now. I mean, I can't tell the difference how it looks, right? So there was something, some special character, something came across from the PowerPoint. How old are you? So we can try a couple of different things here. If the age is, let's make the age not bigger than 18. So we go into the else. So what if the age is 17? So just looking at the program, if the age, this is going to be false. So we should go and do a printout which says you got so many years remaining until you're 18, right? Yeah, you got 1 year remaining before you'll be 18. So how it worked is we got the input and it went and it did this. And it always says, have a nice day. It always says, have a nice day, because have a nice day is outside the if statement. So that's the next example. We'll do elif, I guess. Anyway, so this is kind of fun. And so, yeah, the last example, elif is kind of unique to Python. What most programs do is they'll say else, and then you'll open it. You do the else when you do the open a braces, and then you do another if statement. That's how you do it in most programs. So in Python, what we do is we got this special thing called elif. And notice with the elif, we got another condition. So there's two conditions in this statement. We got the condition one. If this condition is true, we do this stuff. But if it's not true, then we check to see another condition. That's why we do the elif. We're saying, oh, well, that condition's not. So true, we do, true, we do this. False, we do this. But what we're going to do with the false is we're going to check another condition. And if that condition is true, then we do that. Now, if this condition is true, we're not going to do this. All right. The way this is structured is only one of these three things is going to happen. Okay. It's not two of them or three of them, only one of these things. This is a really nice sort of tool that we have. What's going to do is it's going to either do this or it's going to do this, or it's going to do this, but it's not going to do two of them. It's not going to do three of them. One of the three things is going to happen. So that's a nice way of choosing one of multiples, is use if, elif, else. And you can have as many elifs as you like, right? You're not limited to one elif. You can have a bunch of elifs. So for example, if you wanted to say, enter your mark. Mark is 95. So if mark is bigger than 90, A, elif, mark is bigger than 75, B, elif, mark is bigger than 60, C, else, F. And you could do that. It's a very nice sort of thing. So let's look at this. Here's our program. We've updated it a little bit. I'm not going to, oh, sorry. We have an error in there, right? And I don't want to fix the error again. So I'm just going to add the else. So just take that and put that into our little program. So the else is there, but I'm going to add another else, right? Well, that won't work, will it? That's what you're thinking. That won't work. Well, yeah, that won't work. We got too many have a nice days. So this else is going to have to be changed to an elif. And if it's an elif, it has to have a condition. And so what the condition was is yeah. I'm not sure if I got that right, Yeah, okay. Well, our condition is, our result is going to be different. But yeah, it was if the age is bigger than 12. We had two conditions. We had the age bigger than 18 and we had the age bigger than 12. And if the age was, I don't think we said that, right? Yeah. Yeah, it's going to be that. Oh yeah, we could leave it like that. Let's have a look. Make sure I got it the same. Yeah, so that's the same. All right, so sorry about that. So what we're saying is if the age is bigger than 18, then we double it. If the age is bigger than 12, otherwise we're going to say you're too young. Let's try that now. Let's do it with the three different ways. Let's say that the age is bigger than 18. So let's say 20. It should say in 20 years, you'll be 40. Okay, in 20 years, you'll be 40. Have a nice day. Then we're going to run it and we're going to do it. This time we're going to do the age is going to be 15. If it says 15, it should say in 3 years, you'll be old enough or something like that. In 3 years, you'll be 18. Yeah. All right. So that's working. And then the next one we're going to do, they're going to be 11 years old. And now it's going to say you're too young. Right. So it works perfectly. Now notice only one of those three things happened every time, right? Only one. So here, when we said they were 20, the only thing we got was, double the age. When they said they're 15, what we got is years remaining until you're 18. When we said they were less than 12, all we got was you were too young. So this is a good way of choosing one out of multiple choices. If condition, elif condition, else. Right. So we do the else for the last condition. What the else means is everything above is not true. Right. Nothing is true. That's what we get with the else. With the first elif, what we meant was the first thing is not true. Let's see if this thing's true. And then lastly, if nothing is true, then that's the else. And guess what? We kind of ran out of program time there, right? I think, sorry, not program time. We've run out of notes. And so that, I hope you guys will go ahead and do this now. What I'm recommending to you to do is make sure at home you've downloaded Python. When you download it, it'll come as idle, and you can start playing around, writing some little bits of code. You can look straight away on I've made this open for you. You can have a look at Lab 7, and you can have a look at Lab 8. You don't have to, because we will cover that in class. All right, we'll cover that in class. I won't do it today, but we've got another day or two to do this. So I'm kind of finished lecturing to you. I'm sorry, this is a bit of a short lecture. There's wasn't much in it. But this is what you've got remaining to do for this week. Lab 7, Lab 8, and then you've got the assignment, which is to make sure that you've finished your tasks in code.org. You can use the time now to work on that if you want, and I'm happy to help you. Otherwise, sign the thing and I'm done. Okay.
It's not necessary to complete the task between 3 and 10.
Sorry.
It's not necessary to complete the task between 3 and 10.
Let me see that. Cannot minimize those. Okay. So I'm going to end this